Chaos attractors are this cool and amazing-looking math functions that attracts nearby points towards into itself chaotically. Here, chaos means the 2 points, which even though are very near each, can take very different paths as the time goes on. First, we are going to take a look at some popular chaos attractors implemented in Roblox along with their code. First things first. Let's set up the function that will be needed to set up few things. First, we are going to need lots of parts for creating the structures. That's why we are creating this function. We need the parts to be transparent, shouldn't collide with each. Then we will create a trail object for the part for tracing out the structure we are going to create. I'm choosing a gold color to white color transforming trail. And the following configurations now, with this function, we can proxy for the second part. We are going to create a table, which is going to keep track of all the parts. We are also create a variable for how many parts we want to spawn now. We choose 2 limits, minimum position change and maximum position change. These variables are going to be used for spawning location of the parts. This is a simple segment of the code where we choose random location within the position change space and spawn and store the part in the table up until now. All these steps will be same for all the chaos attractors. But you may have to change the position space. Our first case is Thomas Chaos Attractor. I'm going to teach you how to translate the equations to code. Here, dx means the change is x-axis, and dt is change in time. So, everything you see with AD near it shows it's the change. Example, now take a function, dx by det equals 5, to translate to code. We send the det to right side dx equals 5 times det now. What did I say as dx? Change in x-axis. So dx can be written as new x minus old x, so our equation turns into x new minus x old equals 5 times. The reason why we didn't change det is because it's the time step, much like ticks in Minecraft, but for this math function. Choosing dt is important, as it might break the function. So test around from dt value of 1 to 0.001. Now let's get back to Thomas Attractor. Based on the information on the internet, the b value for a proper beautiful output is 0.19 now. The translation of Thomas Attractor's math to code will be as follows. So this function takes in a part and updates its location along the Thomas Chaos Attractor. As we learnt before, we have implemented the function. From the math equations here, we have introduced another variable called scale. This scale value controls how big the structure should be. And now for the final component of the script, code, that's responsible for updating the part's location and creating the beautiful structure you see. We are using heartbeat service for moving our parts every frame, and we just update all parts. Now it's time for the output, the Thomas Chaos Attractor. I have provided the GitHub link to scripts of various Chaos Attractors in the description. Thanks for watching. If you have any doubts, post in the comment section.